So I'm John Cantrell. I've been working on BDK and LDK and this project called Sensei through a Spiral grant. And so today I'm going to kind of walk through a little bit about what is Sensei, going to go over the Bitcoin development kit, Lightning development kit, and then kind of how Sensei uses those and kind of how it's structured. And then hopefully we'll definitely have time for a demo and then maybe a little bit of get it set up on your guys' computers and run the 1,000 nodes and 1,000 channels and all that stuff that I've been pumping on Twitter. So what is Sensei? Sensei is a Lightning node. It's built on top of both these projects, the BDK and LDK. You can think of it in the same class of applications as like an LND or Core Lightning or async. It's not its own Lightning implementation in the sense of, I'm not implementing the protocol specifics. That's what I'm using LDK for. But it is kind of a put together full node with APIs and long running server and all this. It's a binary application. It's focused on being lightweight, modular, and reliable, which are kind of generic terms. So let's talk about that a little bit. Lightweight, I'm kind of referring to the low resource utilization. So it kind of has this goal of being able to run thousands of nodes on a Raspberry Pi. I finally was able to do a little bit of benchmarking this week. It seems like roughly about 130 kilobytes of memory per node. To be fair, that's just like created and started. There's no channels or payments routed, so that number will bloat. But I've also haven't really done any optimization, so hard to know where that will shake out. But currently, it's smaller than I thought it would be, and it's about 60 milliseconds to create and start a node from nothing. Modular. One goal of this project is to be able to start the node in independent modules. So certain modules are like the network graph and routing. So you might want to stand up a Sensei instance that you can use as kind of a pathfinding API for your mobile app or whatever it might be. Or maybe stand up an instance that just runs the chain state monitoring and chain syncing. So, keeping kind of like an API to keep things in sync with the latest tip. And then remote signing is another cool option here. I'm working with the VLS team, which is a project called Validated Lightning Signer. And basically the idea is with Lightning, you kind of need your keys online so that you can continue doing all the channel updates. And so if you could do remote signing where you keep the keys in kind of a more secure location, but could still validate and sign the transactions as your channels are updated. And so they're kind of working with me to get this implemented in Sensei, which I think will be really cool. I think it currently works with Core Lightning. And then reliable, which is, again, very generic, and every project pretty much wants to be reliable. But some things towards that goal are that Sensei supports SQLite, MySQL, and Postgres backends already out of the box. So you can kind of rely a bit on infrastructure that already exists to make those things reliable. And then it has this cool feature that LDK provides called phantom payments, which is basically you can have a cluster of nodes that all know about each other, and they can create invoices for a phantom node, like a node that doesn't exist. And then when someone's trying to pay you, any of these nodes in this cluster can fulfill that invoice. So if one of your nodes goes down, or if one of your nodes doesn't have liquidity, when they retry the payments, they can go through this set of cluster of nodes, and hopefully one of them will be able to fulfill the payment. And then lastly, it leverages these two other projects, BDK and LDK, so it sort of outsources a lot of the hard stuff in some sense to these other teams who are entirely focused on their independent projects. So, it's almost like that mantra of like not re-implementing your own cryptography. Well, I'm not re-implementing the protocol specifics or transaction building specifics or anything like that. So I can have a little bit more confidence that there's not horrible bugs. Okay, and so Bitcoin development kit, what is it? Well, basically it's a way to easily build Bitcoin wallets. And so the idea is that when you build an app that is a Bitcoin wallet or needs a Bitcoin wallet inside of it, there's a ton of functionality that everyone needs to build. And it's kind of stupid to have every app and every developer rebuild all this functionality. And so it kind of tries to create like a easy to use set of functionality that everyone needs when they're working on this. And so one of the things it does is use descriptor-based wallets. I'm not sure how focused or how much everyone knows about descriptors. They're not really that new, but yet they're not that widely used yet. But basically, they're like a easy way to write down to describe the script that you're going to use in your wallet. And so this is really useful when you have complex scripts. So if you're doing something like multisig or time locks or kind of some complicated taproot setup, you don't want to have to construct the script manually when you're building transactions. And so a descriptor, you can kind of describe it in a higher level language, and then it gets sort of compiled to an actual script. And more importantly, I think, is this portability idea. So any wallet that uses descriptors, you can kind of move your wallet into the other wallet and kind of get access to all your coins and all of your addresses without having to worry about like this project dying. Like if you know the descriptor that the project used, then you can easily port it over to any other wallet that uses descriptors. Here's some examples. I don't think we have time to go into it, but you can look on, this is from the BDK website. There's other talks that go over kind of descriptors and the different options and how you write them. And so BDK is built to be really flexible and customizable so that, not all wallets are built the same. You might be running on a server, you might be running on a phone, you might be running on an embedded device, I don't know. So it doesn't try to assume, how you're building your wallet. And so the ways it achieves that flexibility is kind of outlined here. One is what we talked about is the wallet descriptors. You can kind of pick and choose exactly how you want to construct your addresses and your scripts. The next one is the database you use. So if you build a Bitcoin wallet, you need to be able to save your UTXOs, save your transaction history, these types of things, and you're going to need a place to put them. And so out of the box, it provides in-memory database, a SLED database, which is a simple key value. It provides SQLite, and more importantly, it's sort of generic over this database type. You can implement any backend as long as you implement the set of functions it needs to operate, and then give that to BDK, and it will just use it like any of the other databases that it provides. And similarly, you need access to chain data. So you need to be able to know about new blocks when they come in, the set of transactions that are coming in, the current mempool, like to do fee estimation. And so every wallet kind of needs this type of functionality, and so they provide multiple backends that you can hook up to. So Bitcoin-D, Electrum, Explorer, compact block filters. And so how you pick which one to use for each of these components sort of depends on your application. Like if you were building a desktop or a server application, you probably rely on Bitcoin-D. If you're building a mobile wallet, you probably rely on Electrum or Explorer or compact block filters. So you can kind of pick and choose or build your own if you need it, depending on your use case. And sort of the core thing that BDK provides is this wallet structure, which is going to do the address generation based on your descriptors. It provides this like flexible transaction builder. So you can, as it sounds, you can build and construct transactions exactly as you want. And then it's going to do transaction signing for you. And so let's walk through a couple examples of what that might look like in BDK. And so this API is still in flux a bit, but currently I think it looks like this, where you kind of set up your descriptors. Your external descriptor is like your receive addresses that you're going to give out to people or how you fund your wallet. And then the internal descriptor is for your change addresses when you make a transaction and need to send the money back to your wallet. And so when you construct a new wallet, you give it your descriptors, you tell it what network you're working with, you give it a database and a blockchain. And so in this case, we're using the in-memory database and Electrum blockchain using Blockstream's public endpoint. Once you have your wallet, you can get new addresses, just like this, and they provide a couple ways to get these addresses. So this is showing address index new, which just says every time I call this, give me a new address. This can potentially be dangerous because if you're not using each one and not keeping track of that, then you could create this large gap of unused addresses, which could be a pain when recovering your wallet. And so they also have strategies like last unused, which is what I typically use to show kind of the last address that has no transactions associated with it. And it will keep giving back that same address to kind of show as like, hey, this is your next receive address that you haven't used. It provides a sync functionality, which will use that blockchain that you gave it to sync to the latest tip and make sure to update the database's set of UTXOs and transactions and everything. So that when you call something like get balance, it can sum up all the UTXOs in the database from the sync and show the user, a nice balance of how much sats they have. And then this is an example of that transaction builder I keep talking about. This is a simple example where you're creating a single recipient or a single output. You just give it the address or the script and how many sats you want to send. And in this case, we're enabling RBF on the transaction. And then when you call finish, when you're done, this has about a dozen methods on it. You can go look at the docs to see all the cool features you have of this transaction builder. But adding an output is sort of the simplest thing. And then when you call finish, it's going to give you the transaction in PSBT format. And then when it's time to sign and broadcast, you can basically tell your wallet, hey, sign this PSBT transaction, whether or not it created it or it's from some external, it's from a cold card or it's wherever it might have come from. The wallet can sign it, assuming it has the keys to sign it. And then when it's time to broadcast, it has a nice method to extract the raw transaction and then broadcast it using the blockchain you provided your wallet earlier, or really any way you want. So that's basically a quick overview of BDK and how it helps you build a Bitcoin wallet. Then there's this Lightning Development Kit project, which is the simplest way to integrate Lightning into your Bitcoin wallet. So after you've built and tested your Bitcoin wallet, and now it's time to add Lightning functionality, you might reach for this. And so they have this diagram. I think it's a little outdated now, but it's a little overwhelming when you first look at it. It took me a long time to be a little more comfortable with it. So we'll kind of dig into pieces of it, but this is sort of like the highest level view of what LDK is and the pieces that it's made up of, and whatever. So let's just go in. So what exactly makes up a Lightning node? There's kind of a lot of components that go into it. This is not all of them, but these are some of the higher level ones that you might work with if you're trying to put together Lightning functionality. Thank you. In your node. And so there's chain monitoring, there's P2p networking, there's channel state management, on-chain transaction handling, the network graph, routing, payments, persistence. There's a lot. So let's look a little bit at each one. So chain monitoring. So this is, Lightning is a layer 2 protocol, meaning that it relies on layer 1. And so you need to monitor the chain when you open channels, when you close channels, and you're basically, the most important thing, I guess, is maybe monitoring to make sure your counterparty isn't trying to cheat you and publish an old state or something where you'll need to penalize them. And so LDK exposes a couple nice things to make this really easy for you. Maybe the most important is this concept of a block source, which is very similar to BDK's blockchain. And the idea is it's an object that provides functionality for getting a block or getting a header or getting the best tip. And then there's these channel monitors or chain monitor or channel manager. There's a couple objects that care about this information. They need to be notified when new chain data comes in. And so instead of having to hook this up manually, they provide this nice crate called Lightning Block Sync, which kind of does this all for you. And so you basically can give it your block source, like where you get your chain data from, and you can give it a bunch of things that care about chain data, and it's going to sit there and manage reorgs and keeping things in sync and pushing that data to the objects that care about it. And so here's like a really simplified example of what that might look like. In the first section here, I'm creating a block source that's using Bitcoin D client, which is something that they provide in the sample node. And then I'm using that Lightning Block Sync crate to create a polar given that block source. So it's just going to use that block source to get the latest data. And an SPV client that takes the polar and this listener, which we didn't define here, but basically it can be those channel monitors, it could be your channel manager, it could be anything you write that implements this listen interface. So basically it's something that cares about the chain events. So when blocks are connected, it's going to tell this listener about it, basically. And then all you need to do is basically poll this client. So just loop forever and say poll best tip. And this will automatically handle pushing a new chain state into the listener. And then then we get to P2p networking and the messaging. So this is things like connecting to your peers and accepting inbound connections from your peers, and then speaking the Lightning protocol. So you need to be able to speak all the messages that are defined in the bolts, and obviously you don't have to write this logic yourself. And so LDK provides, there's more than this, but basically peer manager is kind of the high level object that that manages all your peers and all the communication with your peers and kind of passing those messages to the relevant pieces of your node. And so they provide something called Lightning Net Tokyo, which is a networking library that handles all the reads and writes at the networking level. And so you don't have to worry about that either. And I think this is just for Rust, but I think they provide similar type of networking help in all the languages they support. This is a little more code, but basically your peer manager needs to take a message handler so that it can handle, basically there's two classes of messages that you're going to deal with on the Lightning Network, which is the gossip messages about what new nodes exist, the channel updates, new channels, and those are primarily used to update your network graph. And then there's going to be kind of the channel messages. So this is like adding new HTLCs or removing HTLCs and other things that are going on with your channels with the peer. And so the peer manager is the one that's in charge of handling all these messages for all your peers. And then you can see here, I'm just binding on a P2p port and then listening for new connections. And that Lightning Net Tokyo crate that I talked about makes it one line of code for, anytime a new connection comes in, I just give it my peer manager and that new connection, and they'll handle everything from there. And same with if I want to connect outbound, they have this nice helper where I just give my peer manager and some information about what peer I'm trying to connect to, and everything's handled. So it really just makes, all this is basically all the code you need to handle that with LDK. Channel state management. So this is kind of a lot of the internals of dealing with when HTLCs are added or removed and forwarded and everything, and making sure that you're persisting the state as these updates happen. And so again, this Lightning block sync crate is important for this because the channel manager ends up being one of your listeners who cares about channel state. The channel manager also receives information from the peer manager from those channel messages. And so this isn't as interesting to look at from code, but basically you need one of these guys to deal with all your channels. This is a little bit of work that they push onto you. If you're implementing a node, you need to be able to deal with on-chain transactions and on-chain UTXOs, or I guess, I'm not sure there's off-chain UTXOs. I guess there are off-chain UTXOs. And so this is channel opening and channel closing transactions primarily. The commitment transaction is sort of handled internally to LDK. You don't really need to worry about it. And they expose this through this event handler. So it sort of bubbles up internal events from LDK that says, hey, this is happening or this is happening. Sometimes you need to react to it. Sometimes you just might need to, it might be interesting to know depending on your use case. And then of course, it depends on having an ability to broadcast a transaction and get the current fee estimate. And this is something where maybe BDK could be helpful for that. And so when you open a new channel, they're going to bubble up eventually an event that's this funding generation ready event. And basically it's like, hey, I don't care how you do it or whatever, but here's the output I need you to create. It's going to have this script and this amount of Satoshis, and just give me the transaction when you're done. And so this is where Sensei uses BDK to use that transaction builder to construct a transaction to fund the channel. And you basically give it back to LDK and say, hey, here's that channel you asked for, or here's that transaction you asked for. Can you please finish opening the channel for me? And similarly, when you close a channel, LDK is going to bubble up this event, spendable outputs that basically says, hey, we handled closing the channel for you. Here's a bunch of outputs that are now yours. Do what you want with them. And the easiest case is just to take them and create a transaction that sweeps them back into your on-chain channel or on-chain wallet. But you could be a little more fancy and kind of save them for later and use them in coin selection separately and saying, when I'm building a transaction, I could spend these along with my on-chain UTXOs. It's a little more complicated, but it would save you the sweep transaction. And then there's network graph, routing, and payments. So this is all the gossip graph updates, using the graph to find a path to pay your invoices, and then generating invoices. And so LDK provides basically helpers for all these things. So there's a network graph object that maintains the network graph for you, a router that helps you find paths using that network graph, a scorer, which is sort of like a way to improve your pathfinding over time, and it keeps track of, it scores your channels essentially as you use them, so that in future routing attempts, it can use that information to be more reliable. And then it provides a high-level invoice payer, which does what it sounds. You give it an invoice, and it will handle all the retries for you and make sure that it can pay the invoice or fail otherwise. And so this looks something like this. You basically can create a network graph at the top here, and then give it to your scorer and your router. And then you can create a new invoice payer using those guys. And then at the bottom here is an example of creating an invoice and then paying an invoice is pretty simple. So LDK, again, makes all of these, implementing this pretty easy. And the last thing I'll talk about with LDK is persistence, which is maybe one of the most important things because it's the main place where if you screw up, you can lose money. So of course, LDK provides a lot of help here. They have another helper battery crate called Lightning Persister, which has basically structures for serializing and persisting the channel monitors, the manager, the score, the network graph, basically all the objects that we talked about today. There's ways to persist them. And then there's this KV Store Persister trait, which is something I was working on recently. And basically the idea is if you just implement this one method, a way to take some key, some identifier for a file or for any object, and the bytes that need to be persisted, you implement this one thing, you basically get persistence for all of these objects. And so this makes it really easy to add any backend to your Lightning node. So you could implement this function for Amazon S3, IPFS, maybe like an op return on blockchain, I don't know. Basically, you can persist your bytes anywhere, and then you basically get all the persistence for all the objects for free. So this is kind of a quick whirlwind overview of what's inside a Lightning node and how LDK can help you implement all of that functionality. Let's take a look at how Sensei uses both BDK and LDK, and how does it support multiple nodes? Does it have APIs? Does it have a web UI? What exactly is going on here? So if you were to set up multiple nodes with other implementations, it might look something like this. You'd have just copies of everything in each node. You'd have multiple block sources, multiple polars, multiple routers, multiple network graphs in every instance you stand up. And what Sensei tries to structure it a little different. You basically extract all the things that can be shared essentially across multiple nodes into the single Sensei instance. And so it's going to have one block source, one polar, one broadcaster, one fee estimate, one network graph, one router, et cetera. And so when you create a new node, the only things that you're duplicating now are the on-chain wallet. Each node is going to need its own on-chain wallet. It needs its own channel manager to manage its own sets of channels. And it's going to need its own peer manager because each one can have its own set of peers. There's some missing things, but this is the general idea. And so one architecture decision here is that there's going to be a single block source, single polar, and a single listener. So it uses that Lightning block sync crate we talked about, and its own block source, which is the Bitcoin D client, and a single polar to implement these objects I'm calling the Sensei Chain Manager and Sensei Listener. So basically, the idea is that if we look back at like this picture up in here, there's going to be a single polar that's asking the block source for new blocks and a single listener. You remember when we had the Lightning block sync that was pushing block events into a listener? So there's a single global chain listener that it's one place that kind of is a sync for all the block connected events. And every time you start a new node, it's going to register itself with this chain listener saying, hey, I'm interested in receiving block connected events as well. And so bringing a new node online looks sort of like this. There's sort of a bug potential here where you could miss a block because there's global polar constantly connecting new blocks. And when you start up a new node, you need to sync it to tip first, to the current tip. And so what you have to do is pause the global polar so that there's no new, the tip is sort of locked. It's not going to change. And then you bring that new node to tip, and then you can register that node with the global listener and then resume the polar so that it can get updates going forward. The other interesting thing here is there's going to be a single network graph and a single network graph message handler, which means the first node that you create is responsible for managing the graph. Okay, so it's going to be the one who has this, who's dealing with the gossip messages from its peers. All the other nodes don't receive or have to process the gossip messages. So this is what helps them stay lightweight because only one of them is doing all the talking about the network. And they have the sole responsibility of updating the network graph for all the nodes. This means that the first node needs to be well connected. You can kind of think of the first node as like your main node. It's like your node that you would have if you ran LND or Core Lightning. You're still going to have to tend to it like you would a normal node. But it does mean that all the other nodes don't need to deal with that. And then all the other extra nodes will just find paths and pay invoices using that singular network graph that gets updated. How does Sensei use BDK? Well, each node has its own on-chain wallet. It's using single signature native SegWit descriptors. Nothing fancy, at least yet. It uses that transaction builder to do the open channel transactions and for generating that sweep transaction when you close a channel. I couldn't reuse any of the existing database implementations that BDK provides, so it's a custom one. I wanted it to be the same database that is used for the LDK data and the Sensei node data, and just have one singular database for all the data instead of separately. And that also meant I couldn't really use BDK's blockchain for syncing. I could use it, but it didn't make sense to have two separate processes that are syncing on-chain data and then Lightning Block Sync syncing the Lightning data. So I was able to reuse Lightning Block Sync and treat the BDK on-chain wallet as just another listener who cares about these block-connected events. And so when a block is connected, it takes that and updates the database of UTXOs and transactions that the on-chain wallet cares about. So it's all kind of unified under this Lightning Block Sync crate that LDK provides. And then it exposes gRPC and HTTP APIs that you would expect from a Lightning node. It additionally has this like control plane API that I'm calling it. So this is where you can manage the Sensei instance itself. So create list, start, stop, delete the actual set of nodes. And then for each one of those nodes, you're going to get a macaroon, and you can do your typical Lightning node API. So you can open close channels, create pay invoices, whatever. This week I was working on batch open channel API that was mostly for this demo, but also I thought it was an interesting thing to implement. And so it can open up to 1,000 channels with a single transaction. You could probably do more right now, but I guess there's a spec change coming that limits the number of channels you can open per transaction to about 1,000. So that's working. And there's a JavaScript client, HTTP client that is maintained and used in the web admin. So Sensei ships with a web admin built in. So when you start up the server, it's going to serve this app that you can use to manage all your nodes, both the control plane and the individual nodes. So let's get into the demo. And if you guys want to get out your laptops, we can try to get everyone running Sensei if we have time. I don't know how we're doing on time. 2:30. Yeah, we should have time. So I guess maybe first, I can just walk through the web UI too if you want right now, just to get a sense for what Sensei is like here. So,
what's the GitHub?
So you're gonna need. I just did a release this morning, beta release. It's I don't know if you guys can read that. L2 technology and then Sensei. So you have to grab the binary, the Sensei D here, for whichever architecture you're running. I don't know if all of them are supported yet. You could always try to build from source, but that's going to be a little scary.
beta 2?
Yep. So those two binaries, the CLI and the daemon, just grab the daemon. You'll also probably need Nagiri is what I recommend to get Bitcoin D running. I don't know if you guys have that or some other way to run Bitcoin D locally. That you don't need this if you have something you use like Polar or some other way you do Bitcoin development. But I prefer this. It's a little easier. But I guess as people are doing that, I can keep going on a quick walkthrough of what it looks like. So once you start up Sensei D for the first time, you'll get presented with this set up your node. This is sort of setting up the first node on the instance. So if you don't have any nodes, this is what you'll see. So you can pick basically it uses a username password login. So I'm just going to just address. If I come to the chain tab, I can see I have 100 million sats, or I guess 1 Bitcoin, that Nagiri funded. So this is sort of like showing you my on-chain wallet. And now if I come back to my list of nodes, I can pick Bob over here and hit open channel. It'll pre-fill Bob's connection string for me. And I can pick how many Satoshis I want to do. So let's do a 50,000 sat channel. And you can pick its visibility. Let's just do public channel. So now I have a pending channel with Bob, which is another node I'm running on this instance. And I need to mine some blocks. With Nagiri, they don't make it as easy. I forget. What do I do? This here. Oops. Let's see if I can mine 10 blocks here. This doesn't look right. Okay, I need a new address, and then Nagiri RPC, generate to address 10. All right, mine 10 blocks, and now my channel is ready to be used. And so we can come in here and we can log in as Bob. So this is logged in as the root user. And so if I log out and I log in as Bob, so you could give out these nodes to anyone you want, I guess, with username and password. So this is sort of like a way to replicate LN bits or something like that, or LND hub, where each node but each account is actually a full node instead of just an entry in a database. So now I'm logged in as Bob. You can see I don't have that admin section, so Bob can't create new nodes or anything. They only can see sort of the normal Lightning functionality that you would expect. So they can see their channels that they have. They have one with the root node here for 50,000 sats. So I can say I want to receive money. So let's create an invoice. Let's just call it test for 5,000, or I don't know, 500 sats, which is 500,000 millisats. So I create an invoice. I can copy it to my clipboard. I can see down here this pending invoice. If I log out of Bob and log back into root, I can, it's so annoying, I can send money. So I can paste the invoice from Bob, pay invoice, go to send money. I can see I just paid a 500 sat invoice. If I log out and go back to Bob, I can go to channels and I can see I have 500 sats. So that's sort of like the manual demo of how you would use this UI to manage your nodes or let other people manage nodes that you're running for them. And that brings us to my 1,000 node demo, which I'll try to do real quick. So if we log out, let me kill this. Let me delete my Sensei directory here. Where'd it go? Here we go. So I'm going to start Sensei here. There's, you can give it your Bitcoin D parameters, and then there's database URL. Oh, you can't really see this. You can, again, this is how you would define your SQLite, MySQL, or Postgres. I'm just using SQLite for this. And there's a Sensei Workshop. We don't have time for it, but if you grab this repo, it's off of my John Control 97 GitHub. It has a little exercise where you can try to implement this 1,000 node project, and I included the finished version if you just want to use it as a reference for something you're working on the hackathon or whatever. And so if we come back here and run my script, it's going to create the root node, and then it's going to create 1,000 nodes. So this is creating 1,000 nodes on the Sensei instance, and then it's going to do one transaction to open 1,000 channels. Oh, I have it set to 100. Well, we'll do 100 to start. So it's going to open 100 channels and then do one payment over each of those channels.
Is it opening a channel like from dual funded or like from one node?
It's from the root node to all the other ones. So here's the events bubbling up from LDK saying that I initiated the channels, and there's the 100 payments. So it's a little quicker to just do 100, but I can do 1,000 if you want. Otherwise, let's walk through the API a little bit maybe. So this is the script that's running. So it's using JavaScript, which everyone's favorite language. It creates.
Could you expand the process, please?
Yep. Is that too big? I don't know. Whoop. Crap. Is that better? Okay, so basically I provide this Sensei client, which is just it's a JavaScript library to interface with the HTTP API. So you don't have to use it. You can just use the HTTP or gRPC APIs however you want. But I use this one to build that web admin that you see. So if you look in Sensei's root, you'll see there's a web admin folder where you can see the source code for that if you want. It could be helpful for using the API as well. But let's just run through this example. So you create a new client by giving it basically the host to your Sensei instance. In this case, I'm running it on localhost port 5401. I'm getting the status here. Just this kind of gets information about is like the first node running and what version you're running and other like generic information about the Sensei instance. And then here, if it's not created yet, I go ahead and call this init method, which will create that root node, and I give it a username, alias, and passphrase, and then whether or not I want to automatically start it. So this is what we saw when I was kind of setting up the node the first time in that web UI. I was using this method. And the client, since you can work with multiple nodes with the same client, you can set the macaroon or token you're using. The authentication is a little wonky right now because it uses kind of tokens for working with the control plane API. So if you want to create new nodes, you need to use this token authentication. And if you're communicating with an individual node, you need to use the macaroon authentication. So for this case, we're going to be using the root macaroon. We're going to get an unused address. Then we're going to fund that address. This is using the Geary. And then we're going to generate node credentials for however many nodes we want to create. And this is basically just using that faker library to generate alias, username, and passphrase for all the nodes we're going to create. So it's just using random username and password, basically. Well, the password's always password. Once we have 100 or 1,000 credentials, it's going to push it into this batch create node API call to create multiple nodes in one call. That will create all the nodes. Then we need to construct all the channel open requests. And so basically they look like this. You give it a node the node connection string, so who you're connecting to, pub key, IP port, whether or not it's public, the amount of satoshis you want to open the channel for. And so I collect those into a big array of all the channels I want to open. I call open channels. You can give this one channel, you can give it 100, you can give it up to 1,000, I guess. Really, you can give it as many as you want. I guess it will fail after 1,000 soon. And this will open all those channels with a single transaction from whichever node you're currently operating. And then I need to mine some blocks so that the channel can be ready to use once the transaction is confirmed. This is just the helper I had to write to wait for the channels to be usable, because once you mine the blocks, you need to wait for LDK to process it and make sure all the channel states are updated and ready to be used. And then this is just me looping over each node that we created, having it generate an invoice. So I have to switch which authentication I'm using. So I'm setting the macaroon to be this node that I created's macaroon, which you get the credentials back when you create a node. It's macaroon and ID and everything. So I'm temporarily switching to the node saying create an invoice for 1,000 sats. So I get the invoice back, and then I switch back to that root node and I pay the invoice. And so that's what we were seeing there. And so that's basically it. I'm happy to come help people get it set up if you want. Otherwise, I'm also happy to take questions if you guys have it. Yeah?
So if you open 1,000 channels with a single transaction, can you close them individually, or are they all linked into one now?
I believe you can close them individually because you still reference the single output, right? So they each have an output in that transaction. If we log in, we can actually see this a little more carefully. So here's the funding, and then I opened 100 channels, which cost me 35,000 sats in on-chain fees. If I come to my channels, I can see them all here. And you can see the channel IDs are actually all very similar because the channel ID is constructed from the transaction ID and the output that you use. So they're all going to be sort of the channel IDs are all going to be very similar because they use the same transaction to be created. But you can definitely close them individually. Any other questions? Yep.
What did you have in mind with opening, having multiple nodes as opposed to multiple channels? Was it the phantom payments sort of idea?
Yeah, there's a couple use cases. I think one idea is sort of similar to the Greenlight model. I'm not sure how familiar you guys are with Blockstream's Greenlight project, but basically the idea is that you could run, using remote signing, a bunch of nodes on a cloud or on a server somewhere, and have it still be non-custodial because the keys could be on the mobile devices or on your app or wherever. And so I think Sensei could end up being used as an alternative to Greenlight. And I think for now, Greenlight's backend isn't open sourced. I think I talked to Christian and they are planning on open sourcing it at some point when it's ready. So this might be a way to hack your own mini Greenlight when you're ready. So another option is maybe as an LN Bits or LND Hub alternative. In terms of the multiple nodes. Yeah.
So to clarify on that a little bit, does this mean that the admin that runs the Sensei node has no way of knowing the private keys of anybody?
Today, no. Today it's custodial, and then everything lives in the admin's database. But once the VLS team and that integration is done, you'll be able to run it in either mode. So you can run it in a mode where you do manage all the nodes and all the keys if that's useful for your application. Otherwise, you can run it in a remote signing mode, which will be very similar to Greenlight. Yeah. Any other questions?
Can I see the RPC string that you need to launch it with Nagiri?
Oh, sure. Yeah. Looks like this. So I should be on the repo too, but
Yeah, it's on the readme.
I think on the readme, it's like cargo run, and then.
oh yeah, you're right. Yeah.
But if you just have the binary, it'd be /sensei, and then no extra dash.
Yeah, that's a good point. It's here. If you're just trying to run it from source, you need to do what Paul was saying, like this. So cargo run, and then the config. But if you're just downloading the binary, then you would do /binary name and then the config.
The binary name is the Sensei CLI.
No, you want to get the Sensei D.
Okay.
Yeah, sorry. Yeah.
Okay, I see it now in the releases list.
Yeah, it also comes with a Docker Compose file to start up Postgres and MySQL if you want to try those out. And then instructions for developing the web admin if you want to run that locally so you can see your changes without having to be built in.
So you said there's currently a way to do it custodially, right? But
Yep.
there's an admin that's controlling keys from the child nodes?
Yep. Yeah, that's what you just saw. So when I logged in, if I opened up my SQLite database, I would see all the keys and macaroons and everything. I have total control of these nodes. It's.
So you're able to, I see, okay.
I mean, you could.
Are those
Yeah.
via API or is that all via CLI?
Either or both, or through the web admin. Yeah, so you could give your friends like access, like a username and password to log into your node. Yeah.
Yeah, but if I wanted to like spend from my friend's node, could I do that?
Yeah, if you have access, if you're the admin, yeah. But you could give him access such that like you would have you could say it was Bob. He would have his username and password. Oh, what did I make his password? Crap. Oh, I forgot we ran the thing. Let's see. Like you have access to everything through this admin login, and then if I come in and look at my nodes, oh, right. Well, let's see if I can start it here. I forget what the password is. I think it was password. Yeah, it's very secure. Yeah. Okay. So you can start a node, and then I can log in as this person, and they don't have as many. They don't have like the admin access. They don't. All that like node creation and management is gone. It just looks like they can just create channels, open channels, create invoices, and pay invoices. So, yeah. So you can kind of have your little own account system, kind of like LND Bits or LND Hub, but where they're actual nodes instead of database entries. Yeah.
Last time I talked about this, you were saying you were working on like trying to get the child node to come.
The export. Oh yeah, that's a good thing to talk about. Yeah, you have your question. Sorry.
So yeah, I'm just thinking, how far are you on that?
nowhere. But the idea, one cool reason to even use Sensei is sort of this idea that since it uses LDK and all the serialization it uses is the same as LDK serialization, you might want, in the long run for your project, you might want to drop down and use LDK directly because you have some really cool custom use case that you need to. But it can be sometimes hard to get started. They're always making it easier, but it might be hard to get started. So if you start with Sensei, which is kind of like a prepackaged LDK, you can always eject from it and then import that channel state into any other LDK-based node. And you don't have to like reconstruct all your channels and all that. You can just kind of move your channels with you to your new node, ideally. It hasn't been done, but so I sort of think of it like, I don't know if you use like, what's the mobile thing everyone uses? Like React Native or Expo. You can like eject from that, or create React app, you can eject from. So I think you can like eject from Sensei and kind of get the raw data and move it into any LDK-based node or your own custom solution in the future. So that's like sort of one interesting use case for Sensei.
That's really big, I feel like, because there's getting channel state working between channel state backups between different implementations hasn't really been possible.
It's not impossible, but yeah, basically impossible. Yeah, it would be cool to build.
I guess, maybe.
Yeah,
Hard to
someone
do.
has to just do the work.
Yeah.
Yeah. Cool. Any other questions? Anyone get it running? Yeah, there's probably a lot of bugs. Nice.
If I was an admin over a handful of nodes,
Yep.
I'd be able to query their balances to see like how many sats each one has.
Currently, yeah. In the custodial version, yeah.
Yeah, so in the custodial version, can I give a view-only access to somebody? Like, you can only view your node, you can't interact with it.
Not yet. That is so. If we log out to this root, one idea that I was playing with. Oh, it's so annoying. There's these ideas of tokens, so you can create tokens with very specific scope. And so the idea would be like, if you don't want to have your friend's password and you want them to be able to create an account on your Sensei instance, you could create a token that is only like a single use create node permission, so they can use that create node API endpoint one time to create a node on your instance, and you don't actually know their passphrase. And you won't actually know their seed either, since it's encrypted with their passphrase. So this could be a way to do that, almost make it non-custodial today without having to do a VLS.
Is this a new feature? Did you just implement this, or is this?
No, this is probably a few months ago.
Okay.
Yeah, I mean, everyth's sort of new, but
So,
yeah.
piggybacking off of that question.
Yep.
So let's say you did, implement that where they could single out use token, they go in, make their password, and then you don't, it's kind of non-custodial. You don't actually know their key. Does
Right.
that mean? So that means the key is essentially off of the Sensei server, right?
It's on your server. It's just encrypted with their passphrase. So
it
you,
has to be decrypted by their passphrase.
Yep,
Right?
yeah.
Meaning it can't route if they're not logged in. Is that right?
that's right. If it's not started,
Got it.
yeah. And so to be fair, their seed would be in memory still, right? Because you need the keys to be able to do the channel updates and all this stuff. It's sort of the same attack people talk about at Voltage, where like technically the seed has to be in memory. It's very hard to get access to it, and you have to,
So it
But-
might be able to route as long as the seed is still in memory. Like
it would definitely be able to. Yeah. So they'd have to start the node with their passphrase. So basically, when you start a node,
Yeah.
you give the passphrase, it decrypts everything, starts up the instance, and so it's not saving it to disk. There's no.
Got it. And then
Yeah.
you have a server outage, and so it goes down, and you bring it back up, so then
Yeah.
you have to log back
It's
up
the same thing with like L&D unlock. Yeah.
Okay,
It's
just
like.
trying to figure out how it works.
Yeah. Yep.
Are you storing like structured data about the channel manager in your database, or is it just a big blob of bytes for each?
For most of the LDK stuff, it's a blob of bytes. But for payments, and then for payments, I'm storing them in the database. So you can see like this. So like this data is stored in the database, and you can like label it. I don't know if this works. There's there's some payment data. There's an open issue that I need to get to actually store the channel data separately, because if your channel fails for whatever reason, LDK only keeps around like successful channels, and like once you close the channel, I believe that the channel state is removed from the channel manager. It would be nice to see a history of all your channels and what happened if they failed, and so currently that's missing. And so I think moving or adding essentially a table for channel data is something I want to do whenever I get a chance. Yeah. Another question?
They brought up at the LDK talk talking about they're doing the serialization and they just hand you bytes, but I was wondering, is that annoying sometimes?
No, I don't even notice it. So it's that persistence trait I was talking about, where just they give you you get bytes and you just put them somewhere that you know how to get them later. So it's really nice in terms of like the channel monitor, like things you don't care about, and if you do care about it, you still usually need to instantiate it on startup anyway. So you're just reading it back into the object that you can use in your code, and if you need it for some other reason, then yeah, you're going to have to create like a separate table or something to manage that data. But for basic usage, it doesn't matter. Yeah, so I'm trying to get away from the term child node, but yeah, the other nodes all have their own on-chain wallet, their own set of channels, their own set of peers. For now, I think there's going to end up being like 3 or 4 types of nodes, like one that's like a full node, like these ones today, ones that the remote signer where they don't have the seed management, and then ones that are almost like a managed node. So the root node can manage the liquidity, but they have like send receive functionality. I think there's sort of maybe a couple places, like a couple ways you can go with node types.
What's the reasoning behind changing from terminology child node?
Because it's not really a child. At the end of the day, all it's sharing is the network graph and the chain data, and it's not really sharing it. It's not really getting it from a parent node. It's getting it from the Sensei instances, managing kind of a global network graph and a global chain state that is getting pushed to everyone, and they're all using. So there's not really a parent child. The only way that there sort of is that there's that one node that is acting as who's dealing with the gossip messages.
Like a service provider?
Yeah, and I think when I talked about that modularity, the idea is eventually, hopefully in the next couple of weeks, that functionality is actually removed, and you would spin up like a network graph instance of Sensei where it's just that one node managing the network graph, and then all the instances would just use that as a service, basically. So I think in that version there would be even no parent node at all. So that's why I'm trying to get rid of that. They're really just independent nodes, at the end of the day. No one else?
I have a tech support question, but
Okay, I'll come after, yeah. Also, I'd love to see someone do something with this at the hackathon. If you guys, I have a couple ideas if you're looking for ideas for the hackathon. I think there might be some cool things to build on top of the API. I'll tell you later.
It's an amazing piece of work, man.
Thank you.
Really good job.
Thank you.
Does Sensei have on-chain support right now?
First,
General sending, receiving?
it doesn't actually. It could very easily because of BDK. I just didn't expose the UI. Yeah. Go ahead and build it for me. Thanks. Also, yeah, I'm looking for help. There's a couple people adding help here or there, but it's people come and go. So if you're looking for a project to contribute to, we really love the help. Also, someone was helping with Zeus integration, so you can remote control any of these nodes from your Zeus or from Zeus remote control app. And then Umbrel, hopefully, will be, now that they release their multi-node or Lightning implementation app store, hoping to get Sensei on there in the next couple of weeks as well. So you'll be able to spin one of these up on your Umbrel, hopefully in one click. All right.